So we're in business. We have recording. So ladies and gentlemen, we're live. And I'm going to record this. I know, this is the best part. The properties are all those. Not that you don't remember them. They're the cosecant, secant, cotangent. Let's check some things off. Like, you don't need to you don't have to expend any brain power to remember those. We just got finished with it. But it's nice to remember the cosecants, the reciprocal of sine. It might be good to go in there and say, hey, sine of x is also 1 over cosecant of x, for instance. You can go the other way too. Or did you know that cosine of x is 1 over secant of x? If that isn't obvious to you, maybe write it out. And you can do the same with tangent of x is 1 over cotangent of x. These are, to rewrite something is just to help you maybe look at it in a different way and maybe find a way to simplify. So the job that we're going to run into is we're going to find ways to rewrite it because our goal is to get stuff to cancel, to simplify. And if you like the idea of crossing stuff off and canceling, the cathartic feeling of removing stuff, that's where it can be fun. So let's get there. Let's go find things that we can cancel. For instance, on this first one, this is the one that is probably the most accessible on the whole page. If I want to get some canceling going on, one of the tools that we do is we try and write them in terms of the same trig function. So generally we like to write in terms of cosine and sine. Now these are never always statements. When I write this, these are suggestions. It's like this might be a strategy that might work in a lot of cases, and in this one it does, and many like it does. Okay, so you're there. No, so we're just rewriting. We're just doing the fun part, which is like rewriting and simplifying. So if you want to know the definition of proof, proof is deciding or showing that two things are the same. And we'll get to that, but a proof, the way that we're going to get to it later is you're going to say that you're going to justify that two things are the same. Not there yet. This is more fun, I think. Cotangent. You want to write that as, do you remember that cotangent is the reciprocal of tangent, so it's cosine of x over sine of x. So, and we're going to have to pause all reactions. You're just going to go with it. Yeah.
Do you want your coffee back?
I do in a minute. Okay, Sam, Carter, and those beyond you, hold off and just watch. If this causes too many reactions, then we're going to have to go silent here. This, now I know I put x in there. I did it somewhat for your benefit. If you don't like writing thetas, you're more than welcome to replace them with x's. That's fine. But that process of rewriting it in terms of sine and cosine can make it look more familiar, and then the fun stuff can start. So cosine over sine, that's no big deal. 1 over secant of theta as 1 over cosine of theta, which is one of the first things we just saw. Sine of x. Sometimes you want to write it as, since they're all in a ratio form, then writing sine of x as sine of x over 1 is beneficial to this to being able to cancel some of these. And then you go in and you find where you can cancel, like cosine and cosine. And a product of ratios, you can cancel long distance because remember, multiplication is, we call it commutative. You could have rewritten this with sine sitting right here next to cosine over sine. You could have done that. And that way the signs would have canceled. And so the process of canceling long distance in a product like that, I'm going to get that to move out of the way so I can write. There we go. I can actually just cancel the signs from far left and far right. That's okay. What's left when you're done? Just sign. Now this works great when you're simplifying. So you're just left with 1. This is equivalent to 1. If I graphed it in Desmos, it would be a horizontal line at 1. Isn't that interesting? So it's kind of a cool idea. It's just 1. It's one of those, like, if I were to write a really nerdy math t-shirt someday, and I would write, like, weird number, and I'd write that function. Wouldn't that be awesome? Like, weird number, cotangent theta, secant theta, sine of theta. Exclamation point. Yeah, all right. Sam thought it was funny. So cosine and secant, what are we going to do? We're going to write it as sine and cosine stuff. So that's one option. I'm going to give you some flexibility. As you go, think of it as there's often not a single way to doing these things. There's often a lot of flexibility. So I'm going to go in and make anything that's not a cosine or a sine, I'm going to make it into some kind of cosine and sine. And if you like to keep using x's instead of alphas and thetas, you're welcome to. It's no big deal. I'm going to write this as secant. I'm going to make it 1 over cosine of theta. Now, some of you want to go ahead and make that leap and say, hey, if you take cosine times secant, doesn't that just cancel to 1? And that's yes, and you're welcome to make that leap. I'm just being emphatic here and writing everything as fractions, and this would be cosine of x over sine of x. But this is the fun part, where you just rewrite it and you look for things to cancel. We see them pretty obviously. I don't think there's any stress knowing those cancel to 1. Often one of the things that gets people in trouble is that I know I see the canceling, but you want to make sure you actually do the rewriting of it, because it'll save you an error that's likely to happen. At least it does for me. Okay, so cosine of x over sine of x. Things like dividing by a fraction, you have to remember we actually multiply it by a reciprocal. So I'm going to rewrite this. Instead of 1 over cosine over sine, I'm going to take it as 1 times sine over cosine. It's also a good time in your mathematical life to just know that if you do 1 over cosine of sine, it kind of does mean to reciprocate that. It means to flip that bad boy over. So that's it. So 1 over sine over cosine. Now that's, I wouldn't consider that done. That's pretty simplified, right? Just sine over cosine. However, the goal is to get to as minimal a number of trig functions, or even a number if possible. Is there like one more step I could go to get rid of, maybe simplify this a little more? Tangent of x, sine over cosine. So if you can get it to one trig function or one number or a minimal number of trig functions or a minimal number, that would be the goal. Get as minimal as possible. So if I can get your brain back in gear, I need to erase those 2 marks there, whoops. Does that look, that's like the fun part. That's like the area of familiarity that most people kind of like. Example 3 opens up identities that we haven't used as often. So those end up being a little less familiar. I'm going to erase some goobers that kind of bled in there. But it's these odd, even identities. They're actually cooler than you might think. And I'll just give you a quick idea. I'm going to zoom in on a couple of these if I can, if my fingers allow me to. The first one here, if you think of a negative x as a horizontal flip, right? That's the idea of an h flip when we do transformations. If you think of this as a v flip, this is a statement that says if you take sine and horizontally flip it over the y-axis, so it's left to right, you go over the y-axis, that's the same as, an equal sign means the same as, vertically flipping sine of x. So I'm going to draw a picture and see if that's absolutely true. That sounds a little weird to me. So if I take my sine curve and I draw it, here's my sine curve. I'm drawing kind of a couple iterations of it here. So there's my sine curve. And maybe I should cut that off a little bit. Yeah, let's make them symmetrical at least. Ooh, that was weird. Okay. Try it again. Back it up. I'm having trouble with my lines. I can do this, I can do this, I can do this. Yeah, that's what I wanted. Okay, so those are pieces like that. If I horizontally flip these things and I flip it over top, this in another color, if you can't see it, I'll draw it for you. These get turned around backward. Whoa. Like this. That's flipping it left to right. I take the hill on the right-hand side is now a hill on the left-hand side. And like this valley down here on the right-hand side is now a valley over on the right-hand side. So you did a horizontal flip. The identity that I had says, hey, that's the same as doing a vertical flip over the x-axis, negative sine of x. Does that seem right? If I just do a vertical flip over the x-axis, would that produce the same thing? This top piece would go to the bottom. And it does. Like this top goes to the bottom. This top goes to the bottom. It ends up performing the same way. So the only thing that you need to know is that these identities are true, and if you want to ever go justify them and show that they're true, I actually just produced, that was a graphical proof. I did those transformations. So when you guys are thinking of proofs and having some inclination of what they are, it's just justifying why these two things are true. And I just did it graphically. That's called a graphical proof. And it's fine. You can do that. Now we just get to use it. We just get to play with them. They're identities. They're things that are true. They're trustable. You don't have to doubt them. We just we get a chance to replace stuff with them. So, for instance, if you have a negative value inside your tangent and cosecant like that, it often works out to our benefit to change it to a positive version of itself. So I go up to the identity and say, all right, what's the deal with tangent of negative x? And if I go up there and check it out, tangent of negative x on mine, it says it's equal to negative tangent of x, which to me is saying, hey, a horizontal flip is the same as a vertical flip with tangent of x, which is kind of cool. It's like the same one I just did there. But all that means to you is, hey, you can rewrite that bad boy. You can write it as negative tangent of x. It's okay. It's the same thing. Graphically, if I horizontally flipped tangent, it would look the same as me vertically flipping tangent. They really are the same graph in every single way. Cosecant of a negative x, it's got an identity too. So we swap those out. So I go over here and say, all right, cosecant negative x is, not all are the same, by the way. Cosecant of negative x is negative cosecant of x. It ends up, there's a pattern to how these work. If there is an odd symmetry about these graphs, then this identity is the same for all those odd symmetry graphs. They all have the same property where tangent of negative x is the same as negative tangent of x, because these are both odd symmetry type graphs. And that plays itself out kind of cool like. Okay, so we'll talk about that later too. Is that okay with that? Negative cosecant of x. That's just using that odd-even identity process. It's to replace. There are certain identities I will not ask you to memorize, and I'm thinking this might be one of them because it's a cool one. And even when we get to Calc 2, we use these to help us deal with like certain derivatives and integrals. This is the process we do in Calc 2. Are really, really awful, unless you can rewrite it with one of these identities. And we love it when we know there's an identity because it usually means, oh, I can rewrite it. This is going to be way easier than I thought it was. And so you get excited. And when you do that, after that identity, then it's back to the game we just played. Make it sine and cosine. So see if something happens. Go have fun, cancel stuff, see what goes on. Negative sine over cosine, cosecant, negative 1 over sine. If you mix them up, just use the sheet. It's all there. You don't have to overthink it. But hey, that's always cathartic. Do you guys know the word cathartic?
That was a vocab word. Honors.
No way! You guys just had it? Oh, I love that word. Even feels good to say it. So it's positive 1 over cosine. Can you see it? But I know that's one trig function. I know that's good. That's pretty darn simple. I'm pretty excited about it. But if you can write it as a single non-rational, like not fractional, that would be awesome too. Like, that's secant of x. So in the end, this would be awesome. This is the ideal. Is there a rule that says how far you're supposed to simple? Not necessarily, but you want it as clean and as simple and as non-fractional, non-complex as you can make it. Okay, that's your end goal. On to some more. So we're going to pick up the pace a little bit because you get the idea. We're just replacing stuff. We're looking for identities. You are not memorizing them. At this point, we're saying, is there something for that? Do I have an identity for that? Can I replace that? And you start looking around at these identities, and this is a pretty comprehensive list, by the way. We're missing, I think, the Pythagorean identities, which is coming up later. But let's rock.